Today we are going to be learning about exponent laws. Our essential question is, what are the exponent laws and how are they applied? Vocabulary. At the top you see an image that is filled in. We just want to review this. The 3 right here, the big number, is called your base. That's the number you are multiplying. The 4, the small number, is called your exponent. And the whole thing, 3 to the 4th power, is called a power. We also say this is in exponential form. All right, properties. From our investigation, what you did in class today, you should have discovered these things. Product of powers property. Products. When we're multiplying two powers together, we add the exponent. So a to the power of m times a to the power of n is going to be a to the power of m plus n. So if you multiply the powers, that means you're going to add the exponents. Power of a power property. That means we're taking a power and we're raising it to another power. This is when we multiply our exponents. So this would be a to the power of m times n. So this is when we multiply exponents. Quotient of powers property. When we're taking the quotient, we're dividing two powers. We are going to subtract the top minus the bottom. So we take the bottom power and subtract it from the top power. Remember, to apply these rules, they must have the same base. The big number has to be the same. So to give you an example for product of a powers property, if we had 7 to the 3rd power times 7 to the 12th power, we can apply this rule because our bases are the same. So we say this equals the base 7, and then we add the exponent. So it'd be 3 plus 12. So this is going to be 7 to the 15th power. However, if we had the example of 8 to the 2nd power times 9 to the 3rd power, we can't apply the rule because they do not have the same base. So you must make sure they have the same base, then you can apply the rules. More properties. We're going to talk about what we learned in our investigation, plus we're adding in the distributive property. So if we have power of a product property, we have a product, we're taking A and we're multiplying it by B, and we're raising it to a power. So this is when we're going to distribute the power to the two different bases. You see these big numbers, they're different. So we would have A to the m power times B to the m power. To give you a numerical example of that, if we had 6x to the power of 7, well, we can distribute the power to the two bases. We have two different bases, 6 and x, they're being multiplied, and one power that we're distributing. So this would be 6 to the 7th power times x to the 7th power. Power of a quotient property, we're taking a quotient and raising it to a power. So that means we can distribute our power to the two bases. So that would be a to the m power over b to the m power. For a numerical example of this, we could have 3 over x, that quotient raised to the second power. Distribute the 2 to the 3 and the x. So we would have 3 to the second power over x to the second power, which we could also simplify to 9 over x to the second power. So this one is just taking the power and distributing it to the two different bases. 0 and negative exponents. Anything raised to the 0 power is 1. Remember that, star that. That is a very important property that you just need to remember. Anything raised to the 0 power is 1. A negative exponent, right there, we have a negative exponent. If we look down here, there's a nice graphic that talks about negative exponents. In words, it is a power with a negative exponent equals 1 divided by that power with its opposite exponent. So if we look, when we have 5 to the negative third, our power, we change that to 1 divided by that power, 5 to the third. We just change the negative 3 to a positive 3, and we put it in the denominator. All right, so whenever we have a negative exponent, that means 1 over a to the opposite exponent. So if we had 5 to the negative second, that would equal 1 over 5 to the positive second, which we could simplify even further to 1 over 25. So a to the positive n power is really, could be written as 1 over a to the negative n power. So they are opposites. So if you look, you can see opposites. All right, last piece is to put it all together. How are we going to use this? We're going to use these rules to help us simplify exponential equations. Equations, expressions with exponents. Your answers must use all positive exponents. So if you have a negative exponent, you need to change it into a positive exponent. So how are we going to use these? Let's talk about this. We have, in parentheses, a product of 3 different bases. We have base number 1, which is 5, base number 2, which is x, and base number 3, which is y. We have 1 power, so we can distribute that power to all 3 bases. So we get 5 to the second power times x to the second power times y to the second power. Look at your equation and see if you can simplify anything. 5 squared we can say is 25 times x squared times y squared. Now if you notice, I took away the multiplication symbols because they're not needed, due to the fact that a number next to a letter means multiplication. A letter next to a letter also means multiplication. So the multiplication dots are not needed. Second example, we have 2 fractions being multiplied. If we remember order of operations, though, we do need to start with our parentheses. We have 2 bases being multiplied, 2 times d, all being raised to the power of 4. So we want to distribute that power of 4. So we get 2 to the power of 4 times d to the power of 4. I'm going to rewrite the rest of the expression down. If we look here, we can simplify 2 to the power of 4. That's 2 times 2 times 2 times 2, which is 16. When we multiply fractions, we multiply the numerator and we multiply the denominator. So we're going to do 3 times 16 times d to the 4th. Well, we can multiply 3 times 16. 3 times 16 is 48. And then we also have d to the 4th power. That is all going to be over 4 times d times c to the 3rd. If we look, those are all very different. There's nothing we can simplify, nothing we can multiply by. They have to stay different. They're not like terms. Now we have to simplify this. It's a fraction. We can use division. I like to group things by like terms. I'm going to group my numbers together. Then I'm going to group my d's together. And then my c's together. Division. So first off, I'm going to divide my numbers. 48 divided by 4 is 12. Then d to the 4th power divided by d. There's no power there. It's really to the 1st power. So when we're dividing with powers of the same base, we subtract the exponents. So we're going to do 4 minus 1 gives us d to the 3rd power. Last piece is c to the 3rd power. It's all by itself, so it has to stay where it is, which is in the denominator. That answer is in the fully simplified form. Last two examples. First one, we're starting off with y to the 0 power. Well, if we simplify that right away, that's 1. Anything to the 0 power is 1. Times 8 times x to the 6th power, y to the negative 3rd power, all taken to the negative 2nd power. We have a power that we can distribute to our 3 different bases. So first we give it 8 to the negative 2nd power, x to the 6th power taken to the negative 2nd power. It's a power of a power, which means we are going to multiply the exponents. So 6 times negative 2 is negative 12. Y to the negative 3rd power taken to the negative 2nd power, we're going to do negative 3 times negative 2, which gives us positive 6. We want to make sure our answer is in positive exponents. So 8 to the negative 2nd power is 1 over 8 to the 2nd power times x to the negative 12th power is 1 over x to the positive 12th power. And then y to the 6th power stays in the numerator. Put that all together. We multiply our top, our numerator, and then multiply our denominator. Well, 1 times y to the 6th just leaves us with y to the 6th power. 8 squared times x to the 12th times 1 is 8 squared times x to the 12th. One last thing we can simplify is 8 squared, which is 64. So we get y to the 6th power over 64 times x to the 12th power. Last equation. Start with your parentheses. We have 3 times x taken to the negative 3rd power. Distribute that power to both bases. We get 3 to the negative 3rd times x to the negative 3rd, y to the 4th, all over negative x to the 2nd power, y to the negative 6th power. If the negative is not included with the x in parentheses, this just means it's saying negative 1 times x times y. That can be confusing, so watch out for that. This is not saying negative x, it's saying negative 1 times x. So really watch out for that. Now we can simplify. Group together your like terms. So we have numbers, x variable, and y variable. Division. When we're dividing powers, what do we do with our exponents? We subtract our exponents. So we're going to subtract our exponents. Well, 3 to the negative third divided by negative 1 is going to be negative 3 to the negative third. X to the negative third divided by x to the second, we're going to do negative 3 minus 2, which gives us x to the negative fifth power. And then 4 minus negative 6 is going to be y to the 10th power. Last step is to make it all positive exponents. 3 to the negative third we write as 1 over 3 to the positive third. X to the negative fifth is going to be 1 over x to the positive fifth. And then y to the 10th is y to the 10th over 1. Simplify what's left. 3 to the third is 27. 1 times y to the 10th is y to the 10th, all over 27 times x to the 5th times 1. All right. That is all I have for you. That is your notes, and we will practice this more in your next class period. Thank you so much. Please subscribe to my YouTube channel.